Okay, statistics fans, we're back. I've cleared my throat, I hope, and we can now answer the other question posed in problem 8.31 on page 328. What sample size should we really take if we want to have a confidence level of 95%, but be confident that the average value is going to be within 8 pounds of the true mean? So we want to limit, going back to my little picture here, we want to limit this arrow so that either side of the true mean is 8 pounds. And our estimate will always be within 8 pounds of the true mean. We'll never be worse off than 8 pounds, let's put it that way. Now, what size should n be? Well, probably it's going to be a lot bigger than 5. I mean, look at here. Even I left this in the 90, I'll put it back to where it was, 2.77. What was it? 2776, 2.776, the answer to the original problem. You can see it's 786. It's 49 pounds, plus or minus almost 25 pounds when we had a sample size of 5. That's a lot bigger than 8. And the boss wants 8. Okay, boss, you want 8. I'll tell you how big the sample size has to be. Well, here's the formula out of the book. It's n t alpha over 2 times s over e, where e is the margin of error, 8 pounds in this case, and the whole thing squared. You can see all they did is take this formula up here that we've been working with to find the interval, e, and because n is expressed as a square root, we had to square the whole thing to get the answer. It's just algebra to get from here to here, so no big mystery. But and the t alpha over 2 is the same, the s is the same, and the e is the same. So all we have to do is plug these values in and get the answer. Now let me make a couple points. First of all, t alpha over 2 requires that we have a number of degrees of freedom. And where do we get the number of degrees of freedom? We don't know that because we're calculating n. N degrees of freedom is going to be n minus 1, right? Well, what we're really doing is using a stand-in for the standard deviation, s. This is our estimate of the standard deviation. So we use the same number of degrees of freedom for the t alpha over 2 as we used for the sample. So in this case, the sample standard deviation was derived from a sample of 5 units. So t alpha over 2 is done on the basis of n minus 1 or 4 degrees of freedom. Okay, so all we have to do is use the numbers we've got up here. It's going to be real easy when I get around to doing it. One more thing though, e. E is really the plus or minus number. It's either 8 pounds this way or 8 pounds this way. If you want to know the total length of this arrow, it's 2e, plus and minus 8 in this case, so 16 pounds total variation. But it's always expressed for this formula as the difference from the center, plus and minus, so 8 pounds. Okay, enough talking. Let's put an equation in here, equals the quantity, I put a parentheses in, t alpha over 2, there's our 2.776, times s, where's s, there it is, divided by e, 8. And we'll just put a little caret here. Oops, that's the stars, isn't it? Caret, and 2 for squaring it. And we get a value of 46. Now, as we know, to be conservative, we can't have a sample size of 46.477. They come in, you got choice, 46 or 47. Which is it going to be? Well, it's going to be 47 because we want to be conservative. So that's the sample size if we want to have an 8-pound tolerance interval here. Now remember, let's restate what we're saying. We can be 95% confident that the average we pick, the average we measure, will be within 8 pounds either way of the true population mean if we have a sample size of 47. Okay, we take that to the boss, and the boss says, hey, wait a minute. 95, there's a 2.5% chance you'll be less and 2.5% chance you'll be right? That's too much. I want 99% confidence. Okay, boss, fine. We'll have a 0.01, which is equal to that divided by 2. And as we saw a few moments ago, we take our little table here, 4.604. Okay, that gives us that t-value. So all we have to do is redo this formula equals the quantity of t alpha over 2 times s divided by e, square the whole thing, 127, so 128. So boss, you can take your pick. Do you want to do 47 and be 95% confident? Do you want to take a sample of 128 and be 99% confident? Well, of course, any boss worth his or her salt will answer that question by saying, how much does a sample cost me? And if you say, well, each sample is going to be $100,000, the boss will say, wait a minute, you're going to tell me that it's going to cost me $12.8 million to be 99% confident? Oh, no way. I can get by with 4.7 million. I think that's the way I'll go. Now let me make sure I got the right answer. I didn't check this out. 47 and 328. 47 and 328. Did I miscalculate? Could it be? C17. Make sure I got the right value here. 604. Did it say 90? Ah, my goodness. Isn't this awful? I got the wrong answer. 99% confidence. Oh, 5 pounds. They changed the number on me. Oh, the boss wanted to be 5 pounds. I'm going to put that over here. And I'll go in and edit my form. I'm sorry. I didn't read this problem carefully enough. I'm glad that never happens to you guys. I like to have a nickel for every time someone does something. Oh, there we go. 328. So it's going to take a sample size of 328 to narrow this range, narrow this range to 5 pounds, down from plus or minus 5, down from plus or minus 8, and to be 99% confident rather than 95. So you get a feel for how these things go. Okay, I've talked enough. I hope you have a great weekend. Be sure to ask questions if you don't quite see this. This is I think, fairly simple. The math is pretty simple. I mean, it's a formula. The trick is in knowing which formula to use, and to get comfortable using the T alpha over 2 table. There is an Excel function for that. You can guess T inverse is TINV. Maybe we'll play with that another time. That's all for now. Have a great weekend, and we'll see you online.